Dynamic scaling automatically adjusts the capacity of your auto-scaling group based on traffic changes. It allows you to define scaling strategies, that is, apply scale-in or scale-out to automatically scale up or down as needed. In this case, scaling is the process of deleting or terminating instances, while scale-out is the process of adding or launching new instances. Now, there are three types of dynamic scaling policies: target tracking scaling, simple scaling, and step scaling. Target tracking scaling allows you to adjust the capacity of your auto-scaling group based on a CloudWatch metric and a configured target value. CloudWatch, as we know, is the AWS monitoring service. So, you can have a target monitoring policy that tracks the average CPU utilization of the group and keeps it at 50%. Also, you can use multiple goal tracking scaling policies together, as long as each uses a different metric. For example, you can have one policy that tracks CPU utilization and another policy that tracks the average request count per target for an application load balancer, or ALB. Target tracking scaling policies support four metrics. The first metric is ASG average CPU utilization, which is the average CPU utilization of the auto-scaling group. The second metric is the average count of application load balancer requests per registered target. The third metric is ASG average network in, which is the average number of bytes received by an instance on all network interfaces. And the fourth metric, ASG average network out, which is the average number of bytes sent from an instance on all network interfaces. So, let's look at an example of this type of policy. In this policy, the metric type is average CPU utilization, and the target value is 60%. As you can see, this policy does not include specific actions to scale in or out. AWS will automatically perform the necessary scales up and down to keep the group average CPU at 60%. That is, if the CPU is above 60%, AWS will scale out to add more instances, and if the CPU is below 60%, AWS will scaling to remove instances. The next type of scaling policy is simple scaling. Simple scaling allows you to increase and decrease the capacity of the group based on a single scaling setting. The scaling setting is based on the thresholds defined for CloudWatch alarms. After performing a scaling activity, the policy must wait for a cooldown period before responding to additional alarms. The cooldown period in AWS is a time interval designed to prevent excessive scaling and allow the effects of recent scaling activities to fully manifest themselves. For example, if you have scaled up to increase capacity due to high CPU usage, the new instance needs time to pass health checks, come into service, and start generating usage metrics. Therefore, there may be a delay before the effects of scaling become apparent. However, cooldown periods can also be a constraint. There may be situations where multiple scaling activities are needed in a short period of time, but the cooldown period prevents this. Now, by default, the cooldown period is 300 seconds, but it can be set to 0 seconds if faster, more reactive scaling is desired. This will make more sense to you when we move on to the labs. So, this is an example of a simple scaling policy that performs a scaling. It includes a CloudWatch alarm with a threshold of 80%. If the threshold is exceeded, an instance is added, and as you can see, a simple scaling policy specifically mentions the type of scaling activity, which in this case is adding an instance. The last type of policy is step scaling. This policy is an advanced strategy that allows the capacity of an auto-scaling group to be adjusted according to the magnitude of a specific metric. So, instead of a fixed setting, this policy allows you to define a series of steps or scaling settings that vary according to the size of the deviation from the target metric. A key advantage of step scaling over simple scaling is that it is not constrained by cooling periods. This means that the scaling policy can continue to respond to additional alarms, even while a scaling activity is in progress. This allows for greater flexibility and responsiveness, especially in situations of fluctuating load or peak demand. Therefore, AWS generally recommends the use of step scaling for applications that require more dynamic and precise capacity adjustments. Here's a clearer example. This scaling policy uses a CloudWatch alarm and sets a threshold for the metric, in this case, 80%. Then, when CPU utilization is between 80% and 90%, the policy will add any C2 instance. If the CPU utilization exceeds 90%, 2 additionally C2 instances will be added. In this way, the number of instances that are added depends on how much the set threshold metric is exceeded. This process is known as alarm breaches. Similar actions can be configured for scale-in activities. So, these are examples of the 3 dynamic scaling policies, each offering different levels of control and flexibility for managing the capacity of your applications in AWS, and we'll see how to implement each of them in the following classes.